I welcome you on Lesson 2, Networking Models and Application Layer Protocols. First of all, let's take a look for the speaking rules which we use during the communication and having dialogues. First of all, when people are making communication, they have to use the common language. They have to wait their turn before they have to start the communication. They have to signal when they start the communication by saying hello, for example. And they have to signal when they are finishing the communication, like saying goodbye. And the same way, computers are using the rules to have the communication. And these rules are called the protocols. And actually, the description or definition of the protocol is that the set of rules is the protocols. And the protocols are used by computers to have a correct communication, like human having the same rules. Now let's take a look and discuss what is the model is. When I ask my students what is the model, they usually say that the model is the small car, as an example, the toy car, which is representing the real car. So when we look for the picture of this car, we may think that, this is just the shape or the model of the real car, and it means that we have the real car which is looking like same, but additionally it has the real engine and so on with the real size. Also, when I ask from my students what do they think when they hear the word model, they think about the fashion. And so for example, this is the fashion model, and like expectation and reality. So they are quite different. Like we have difference between these two cars, and also we have difference between this two views of the same model. I mean, when we look at in the model, and when we have the real clothes like this. Now we'll take a look for a small example in which we'll have with you the small and happy alien which came to our planet, and we have to teach this small happy alien so that he will understand what is the home is, or the building of the house. To do it, we'll have with you two experts, two engineers, let us say, who will teach him one by one. So let's say this is going to be the Beric. This is going to be the Seric engineers. So they are going to teach what is the home is, the house is. And let us say that the Beric decides to discuss about house in some layers. So maybe he will just take it like this and say that, look, my friend alien, this is the fundament. And afterward, look, the house consists of also the doors and also the windows and also the roof, like this. Well, from the other side, Mr. Serik will say that maybe he is familiar with the programming, with the web programming, and he can say that, look, my dear friend alien, the house consists of actually 3 layers. They are going to be let's say header, the body, and the footer. So that when these two engineers will discuss the structure of the house, they will speak actually about the same object. So the house here is the same object, and the explanation about the house here is like let's say the Beric's model, and the second explanation is Seric's model. So by using these two models, this happy small alien will be able to understand what is the house is, what it consists of. The question is, will he understand the same thing when he will listen for the BRX model, and will he understand the same thing when he will listen for the CRX model? Actually, yes, because they are speaking about the same object, but in the different ways. There's like approach of understanding is quite different, but uh, the object which is looked by these two engineers is the same, and we can make comparison. And actually, actually, our roof layer in the BRX model is looking like same as the CRX models layer header. Windows and doors will be same as the body of the CRX model, and the fundament is actually the same as the footer. So from this example, we may see two models, and we can see the comparison between them. To understand the house, alien used one of these two models. To understand computer networks, we use also model. So model is used to simplify and understand the computer networks, and engineers created two computer networks models, and each of them consists of layers, and each layer consists of different types of protocols and set of rules. So the computer networks model is created by engineers to simplify the understanding of the computer networks. And these two models are different between they got the difference between each other, but they are showing the same object. Like we had here an example with the houses with different explanation about the same object. So we have also two models in computer networks which are describing the same object. The object here is the computer networks. They are OSI and TCP/IP models. So if we'll take a look for the description of these models, we may find out here that the OSI model consists of 7 layers, and the TCP/IP model consists of 4 layers. If you want to make the comparison between them, so that you may find out a layer number 7, layer number 6, and layer number 5 are the same layer number 4 in the TCP/IP model. Layer number 4 is the same as the layer number 3. Layer number 3 is the same as the layer number 2. Layer 2 and 1 are the same as the layer number 1 in the TCP/IP model. So what does it mean? It means that the functionality of the application layer of TCP/IP model consists of 3 layers of the OSI model: application, presentation, and session layer. Now let's take a look for the such kind of thing, like I will show you a small pictures. I will actually draw you the small pictures, so they will be looking like this. So we have the capsule. This is the capsule, and imagine that this is the astronaut who is going to enter into this capsule. This is like a sense number 1. Sense number, so it's 2, will be like this person. This astronaut is already in capsule. So let's do it in this way. All right. So you know, it's like a comics, like a first picture and second picture. So we have here the action which is happening. The person entered into the capsule. This process is actually called, this action, so let me define this action, is actually called encapsulation. when one object enter into another object. Well, after what, this astronaut comes back to the planet, and we have a next action. In the next action, we have sorry for my pictures. An astronaut is upset because he exited the capsule, and the second action is going to be called as the decapsulation. So we have the process which is called encapsulation, when one object enters into another object, and when this object comes back again from that object, the process is called decapsulation. Why did I show you this two terms, the encapsulation, decapsulation? Because we are going to use it in next slides. So when your data is traveling between one computer and another, before your computer will be able to send this data have to pass through the encapsulation process. And here we have a small example that is showing us the encapsulation process. In this example, we have the person which is sending the email data. When this data is ready to be sent from the application, data goes down by using this a networking model. For example, in this picture, we will just have the TCPIP model, and our data, when it is on layer, when it is in application layer, our data is called just the data. Afterward, when this data comes to the transport layer, in transport layer, this data is segmented into small pieces of data. And actually, from the previous lesson, you have to know what is the segmentation is. The segmentation is just the division of data into small pieces to prevent such kind of problems like of the lost data and so on. So afterward, to each piece of this data, so this is one piece of data, so like this, we have additional header. So this is additional information in which we have information from which application this data will go and to which application this data will travel. Well, and our data, small piece of data, will become a segment. It's like, you know, we have this data, and it is in capsule of the segment. So this is now a segment, and segment itself will go to the network layer, and in network layer, so this part is called segment now. It will have additional header, and this additional header will consist of information from which IP address and to which IP address this information goes. Well, and this segment will be capsuled into the packet now. So now this will be called the packet. And this is the part of the packet now. When it is coming to the access layer, network access layer, then this packet will be encapsulated with the frame header and frame trailer. So here will be main important information is the source and destination MAC addresses. And we may discuss it as the one more capsule, and it is going to be called the frame. But that is why I showed you this example of the encapsulation of the astronaut. So imagine that this astronaut is the data, and this capsule is the transport layer header. And now, let me even write here. So this is going to be example of data. This is transport layers header. This is going to be the segment, and that's it. So this is encapsulation from one layer to another one. But here we have encapsulation, multiple encapsulations. Data will become segment, segment will become the packet, packet will become the frame. All right, we can make comparison of this encapsulation with the matryoshkas. So the smallest matryoshka is actually the data. The second matryoshka is the segment. The third one is going to be called the packet. The fourth one will be called the frame, and the fifth one will be called let's say for now it's like a bit string. And also here we have the encapsulation to bit code, so we'll speak about bit code a little bit later. All right, so when and you see the boss here. Who is the boss, guys? The boss is this matryoshka. Okay, why she is the boss? Because everyone works for her. Okay, it's the main reason why we are generating all this matryoshka is this one, this boss. Well, why the data is going to be encapsulated into such kind of matryoshkas before it will be sent out? Because before sending this data, we have to define from which application to which application it goes. So defines applications. I mean, from which application on computer and to which application. Source and destination define it here. Next matryoshka defines from and to IP addresses. It's like addresses of the networks and the addresses of the hosts. And the next matryoshka, when it's becoming frame, it defines the MAC addresses. MAC addresses. MAC address, it's the physical address of the individual network interface card of your computer. And the bit code actually converts the bit stream into the bit code, so we'll just discuss it a little bit later. For now, we'll just place it like this. But you have to understand that this process, when one matryoshka goes to another one, is called how? Yeah, it is called the encapsulation. So when when your matryoshkas will be delivered by the receiver will delete the header of this matryoshka. Also, it will delete the header of this matryoshka and delete this one and delete this one, because all of these matryoshkas are the temporary. So we just use them to have this one, because it is really very important for us, matryoshka. Everyone, as I told you, are working for this matryoshka. Then the back process, the vice versa process, is called the encapsulation. Let's continue. So actually, this slide explains the same, like data, segment, packet, and frame, and what do we have additional here? The port numbers, which defines the applications, the IP addresses, which defines the source and destination network addresses, and the MAC addresses, which are defining the source and destination physical addresses of hosts. Models comparison. So in TCPIP model, in application layer of the TCPIP model, we have elements of the application, presentation, and session layers of the OSI model, Open System Interconnected model. And by the way, the TCP is like a transmission control. So let me write it here. Transmission control protocol. And IP is the internet protocol. Oh, this is description of this abbreviation. And the OSI, open system interconnection layers. Okay, so that what are functionalities of these three layers? I mean, of the OSI model. The functionality of the application layer. So when we say the application, actually the application is the program. Okay. So when we speak about application layer, so imagine that we are speaking about the programs which are running on your device. The application layer services initiate the data transfer. For example, you open your computer, and in computer you open the web browser. In web browser you type something like, for example, OKKZ. You press enter. So actually you generate the communication because you did this job, but it is happening in the application layer. So the application layer, the program layer, is initiating the data transfer. And also the application layer prepares human communication for transmission over the data. So as this process, when you type it, actually it is your job. So you are beginning the communication, but afterward it's helping you to the process. And the application layer receives data from the network and prepare it for the human use. For example, when you are making request from the computer to the server, and this is, for example, this OKKZ server. So when you type this command, actually your application is generating the message like a, the message like a get index HTML from OKKZ, and afterward it is giving you a reply. So when a reply comes to you, it goes till layer 7 to the application layer, and you may find here the content of this website. Oh, this is the job of the application layer, to generate the communication and actually to terminate the communication and show the result for the owner of this computer. So application layer, as you see here, they are like bounded with each other, but the communication happens like this. And when it's coming back, it goes like this also. And here we have an example of how we can run multiple applications, multiple programs, okay, on the same computer. And so this applications layers will generate the communication, and your communication will pass through all of these 7 layers of the OSI model and will travel to the destinations. And when they will come back again, they will come by the physical layer, and they will be decapsulated till layer 7. All right. The second layer, or not the second, the 6th layer of the OSI model is called the presentation layer. The presentation layer in OSI model is responsible for the coding, compression, and encryption of your files. And imagine that you have a computer which is going to send the data to another computer. So I'm drawing that they are directly connected, like in this example. So for example, we are sending the picture, our photo, and the picture is going to have the name like me.jpg, or we may have the same picture, the absolutely same picture, which will be called me.png. So when the receiver will take this picture, when it will be delivered, the receiver will see, so if you will send me JPEG or me PNG, the receiver will see your face. Okay, he will recognize you, and it's not a big deal, I mean big difference for the receiving person will it receive the JPEG file or PNG, because he will see the content. But when you are working with different types of the files, like here we have the different formats of the file, the JPEG and PNG, they have to be coded, compressed, and encrypted by the format of this file. And that is why the sizes of the files can be different. For example, it can be like a 500 kilobits or kilobytes, and this one can be just only 100 kilobytes. But when you will open these files, they will be looking like same from the first sign, but the structure of this compression and encryption will be quite different. So that is why the presentation layer is responsible for doing these three operations before sending your file. It's like presenting. It is representing the format of your files which you are going to send from your computer, and also to which you will receive onto your computer. Well, the session layer is the layer number 5. It is responsible for maintaining the dialogues between the application, between the two applications. So before starting to communicate between each others, the application is using the resources of the manager, which is called the session layer. So it is making an agreement, and it is maintain this agreement during the communication, and the communication is destroyed also by the session layer at when the application is finished to transmit the data between each others. So it is OSI's 5th layer. Now let's take a look. Let's make pause from this TCPIP and OSI models, and let's take a look for the network models of the communication type, like a client-server communication type, and the peer-to-peer, or like a P2P communication type. So what are the differences between them? So when we are using the model of the networks, of computer networks, which is called the client-server, it is centralized model actually, and we have a server and we have the clients. So in parallel, we may take a look for this example. I didn't prepare the picture for you, but I can draw it for here. So imagine that we have such kind of small scenario. This is the hotel, and this is the reception or the front desk. And here we have the tourists. The tourists are coming to the reception and asking for something. For example, do you have free rooms? The question is, and she is answering yes or no. Next one, do you have I don't know, the room with the 2 beds? And she will give the answer yes or no, like this. So in this situation, these tourists are going to have the role of the clients actually, because they are having a services from the reception. So reception is now giving only the services, and now they are only taking the services. They are not giving their own services. So in this type of communication, we call it the client-server type of communication, when the clients are taking something from the server. Okay, so for example, can you give me the video file? Yes, here it is. Can you give me this audio file? And yes, here it is. Like centralized communication. One server can support multiple users. And when we are looking for the peer-to-peer or P2P connection type, in this situation, every client is the server, and every server at the same time is the client. So like you have example when 2 classmates are meeting each other, and they are preparing for the final exam on some subjects, so that at this situation, person A can share his knowledge with person B, and person B can share his knowledge with person A. So when the person A is sharing his knowledge with person B. At this time, person A is the server actually, server. But when person B shares his knowledge with the person A, at this moment, this client, this person is actually the client. So in here we have also, first of all, he was the client, but afterward he became the server. So like P2P. So this communication type is called P2P. It doesn't mean that when you have the P2P communication, it doesn't mean that only one person is or one computer and another computer, only two computers are communicating with each other. For example, when you have I think that you are familiar with the torrent files downloading. So when you have the torrent type of the file downloading, you have such kind of structure. In all the world, we have computers which are connected by the internet, by the service providers to the internet, and you as the computer A can take files from any other computers like B, C, D, and E, so that this client will give you some files. So when he will give you some files, he will be as a server. But at the same time, computer B can request from you another part of the information which you already took from computer E. So and now you can share with him this information. And every computer is like is the client and is the server at the same time. So this is an example of the torrent downloading. But when you have the situation like you are downloading from the single server, so it means that you are connected to the server and only this server gives you information. And when we have another computer B, which is also want to get some information from the server, so only server will give you and to computer B this information. And if we will have computer C also, so only server will give this information. What are the disadvantages of such kind of topology? Disadvantage is that server is the single device in this situation, and it has the limited resources, so that these computers, so when the amount of these computers will be huge, then the limit will be finished and your server may not be able to have to provide a proper services for all of you. So it's time to speak about the application layer protocols.